Hello students. Now I discuss some problems which are related to the calculation of the stereoisomers. Okay, so here in this case the first question is how many pairs of enantiomers exist for bromochlorocyclopentane. Okay, so you know the structure of the bromochlorocyclopentane. For suppose here we can see this one. Cyclopentane means here bromochlorocyclopentane. How many enantiomeric pairs? For suppose this is bromochlorocyclopentane. This one do not exhibit the optical isomerism. Okay. Now here I am taking 1,2-bromochlorocyclopentane. Okay. And next one more isomer 1 bromo 3-chlorocyclopentane. Okay, so first of all these three are the structural isomers. Now here this can be exist in cis and trans also. So here bromine above the plane and here chlorine above the plane. Okay, so actually here this compound has two chiral carbons and no plane of symmetry. So here this one exists in a enantiomeric form. That means here this bromine below the plane and this chlorine also below the plane. Okay, these two are the mirror images actually. Okay, these two are the mirror images. Now here it is a one enantiomeric pairs. Okay, so cis isomer exists in a one enantiomeric pair. That means here the cis isomer exists in two forms. It is also cis form, it is also cis form. Or suppose if it is a dextro isomer, it is a levo isomer. That means here cis dextro and cis levo. Okay, that's it. Now here it can also exist in a trans form. For suppose here this bromine above the plane, this chlorine also below the plane. Okay, so this is a trans isomer. Now here it's a mirror image like this. A bromine mirror image here below the plane and this chlorine above the plane. These two are the mirror images each other. So it is a trans dextro, it is a trans levo isomer. Okay, these two are the mirror images. So here it is a second enantiomeric pair. Now here this compound also exists in two forms. That means here two geometrically different isomers. So here bromine above the plane, here chlorine above the plane is a cis isomer. We can take its mirror image also. That means here bromine below the plane and this chlorine also below the plane. So it is a enantiomeric pair regarding the cis isomer of the 1-bromo 3-chlorocyclopentane. And here we can have the that trans isomer also. We are bromine above the plane, here chlorine below the plane. It's a mirror image, a bromine below the plane and this chlorine above the plane. Okay, so it is a one enantiomeric pair, it is a one enantiomeric pair because these compounds do not have the plane of symmetry because different groups actually. So here 1 2 3 4, totally 4 enantiomeric pairs are possible. Okay, for the bromochlorocyclopentane. Okay, that's it. And next geometric diastereomers exist for 1,3 dichloro 2,4 dimethyl cyclobutane actually. It means just we have to calculate the geometrical isomers. Okay, for this compound. Actually this is the compound. Okay, so here in this case dichloro dimethyl cyclobutane. How many geometrical isomers for this compound? So for this compound here 5 geometrical isomers are exist. Okay, here in this case this is the one geometrical isomer. Here one group above the plane, remaining 3 below the plane. So in this case these two adjacent groups are above the plane, these two adjacent groups are below the plane. Now here this is the above the plane, here below the plane, above the plane, below the plane alternatively. And next here one more isomer, here one methyl actually below the plane, remaining 3 are sorry, one methyl above the plane, remaining 3 are the below the plane. Here in this case one chlorine above the plane, remaining 3 are the below the plane. Okay, so they are the 5 different geometrical isomers for this compound. Okay, geometric diastereomers exist for this compound means just calculation of the geometrical isomers is enough. Okay, so here this compound has a 5 geometrical isomers. Here in this case, of course, let us check the optical activity of these compounds also. Here in this case, due to plane of symmetry, this compound is optically inactive. And next here, this compound also has a plane of symmetry, optically inactive. And next in this case, this is the below the plane, here above the plane. So here in this case, there is a center of symmetry for this compound, so optically inactive. And next here in this case, this compound also has a that plane of symmetry, so optically inactive compound. And next in this case, you see this one, yeah, here also there is a plane of symmetry. This compound can be cut into two equal halves, and those two equal halves are the mirror images. So here all compounds are optically inactive. The no compound exhibit the optical isomers. Okay, that's it. So next, the one more question is the pairs of enantiomers possible for chlorofluorocyclobutane. Okay, as you can see here, it's a very simple question. This is uh, here in this case, chlorocyclobutane means this one, this chlorine and fluorine, optically inactive compound. So here chlorine and fluorine, this one has a actually cis isomer and trans isomer. Okay, here cis isomer is optically active and trans isomer is optically active. So here in this case we can see like this one, here chlorine above the plane, this fluorine above the plane, its mirror image is this one. Okay, so it is a one enantiomeric pair. Okay, now here I am taking its trans isomer, this chlorine above the plane, this fluorine below the plane. Okay, this chlorine below the plane, this fluorine above the plane, it is also one enantiomeric pair. Okay, it is also one enantiomeric pair. So here in this case, for this compound actually two enantiomeric pairs are possible. Okay, that means here how many optically active isomers? Four are the optically active isomers. Number of enantiomers are the four, enantiomeric pairs are the two. But here in this case, what about the just it is a one floor, that means here 1 comma 3 isomer. This isomer is optically inactive compound. Of course, this compound exists in cis and trans isomers, but no optical isomers for this compound, no chiral carbon. Of course, there is a symmetry. Okay, that's it. And next, one more question: the meso stereoisomers and how many enantiomeric pairs exist for this compound? Here in this case, it is a ethyl group. Here, ethyl group. You can see in this case like this here C2H5, here C2H5. In this case OH, here there is a Cl, hydrogen, this hydrogen, and this one is a OH. This compound is optically inactive compound. So next C2H5, here C2H5, this one OH Cl, this one Cl hydrogen, this one OH hydrogen. This one also optically inactive compound. Because of the plane of symmetry, this compound is optically inactive. Okay, so here in this case, this is the meso compound and this is also meso compound. Okay, now here in this case, so two meso stereoisomers are exist for this compound, and how many enantiomeric pairs are exist? So here for this compound only one enantiomeric pair is exist, OH, and here this one hydrogen Cl, here hydrogen OH. Okay, so now here its mirror image, here Cl, here hydrogen, this is a ethyl, this is also ethyl, here a hydrogen, this one is a OH. So these two are the mirror images and each one is optically active compound. So this pair comes under enantiomeric pair. Okay, that's it. So totally this compound has a four isomers, two are the meso isomers and two are the optically active isomers, nothing but mirror images. So these are the enantiomers each other. Okay, so here one enantiomeric pair and two meso stereoisomers. Okay, so one more important point, these two meso isomers are not identical because their chlorine orientation is different. Okay, that's it. Next year, finally, the meso stereoisomers exist for 2, 3, 4, 5 tetrachloro hexane. So here in this case, we can write the structure like this. Okay, for this compound, we can write the structure like this. Hexane. So here in this case, CH3. How many chiral carbons? Totally 4 chiral carbons. So here chlorine, 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 and chlorine. Here hydrogen, 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 hydrogen. Okay. So here it is also mesoisomer because there is a plane of symmetry. Okay, so here in this case, next CH3, CH3, your hydrogen Cl, here in this case hydrogen Cl, here Cl hydrogen, Cl hydrogen. Okay, so this one is not a mesoisomer. This is a mesoisomer. This one has no plane of symmetry. It's not a mesoisomer. Now here next CH3 and CH3, this one hydrogen Cl, here in this case Cl hydrogen, next here Cl hydrogen, hydrogen Cl. Now here this one also has a plane of symmetry, so this compound is also mesoisomer. Okay, so here it is a one type of mesoisomer, it is another type of mesoisomer. These two are the two different stereoisomers. It is a meso compound 1, here meso compound 2. So here in this case, for this compound, two mesoisomers are exist. Okay, for this compound, two mesoisomers are exist. Yeah, next here for this compound, two mesoisomers are exist, and next here for this compound, total number of stereoisomers. So actually here n equals to 4. Okay, here 1, 2, 3, 4. So totally 4 chiral carbons for this compound, and this molecule is symmetrical. So here we can use the number of stereoisomers formula equals to 2 power of n minus 1 plus 2 power of n by 2 minus 1, that equals to 2 power of 4 minus 1 plus 2 power of 4 by 2 minus 1, that equals to here 6 isomers plus so 2 power of 3, 8 isomers plus 2, that total equals to 10. Here 8 isomers are optically active, here 2 isomers are optically inactive. These two are nothing but meso compound. These two are the active compound. That means here 4 enantiomeric pairs are possible for this compound. So here what are those 4 enantiomeric pairs? Okay, so actually in this case this is the optically active. So here this one has a mirror image, so that is a one pair actually. That means here 1 plus 1, dextro plus levo for this compound. And next here we can write like this here CH3, and here CH3, this chlorine, and here hydrogen, this hydrogen, this hydrogen, Cl, Cl, Cl. Okay, this compound is optically active. For this compound 1 plus 1, that means here dextro plus levo, it is also optically active. Okay, and next here CH3 and CH3, this one actually here in this case hydrogen chlorine, here chlorine hydrogen, here hydrogen chlorine, here chlorine hydrogen. Okay, this one has no symmetry actually. This compound also has a its mirror image. That means here dextro and levo isomers are exist for this compound. Okay, so next the one more compound is this one actually. So in this case yeah, CH3 and CH3. So you can see here like this this is a chlorine, this chlorine actually here in this case here hydrogen, this chlorine and this chlorine. So here hydrogen, this is a chlorine, here hydrogen, this hydrogen. It is also optically active compound. Okay, this one also exists in two forms, dextro plus levo. So here 2, 3, 4, 5, 6, 7, 8, here 9, 10. Totally here for this compound 10 isomers are exist. Okay, that's it. And next here so finally this for this compound meso isomers are the 2, and optically active isomers are 8, and total isomers are the 10 for this compound. Okay, and here meso stereoisomers and for how many enantiomeric pairs this compound, here one enantiomeric pair and two meso compounds. Okay, and for this compound here enantiomeric pairs, it is a one enantiomeric pair, it's one enantiomeric pair, this one another enantiomeric pair, two enantiomeric pairs are possible. For this one stereoisomer, that means geometrical isomers are the 5. Okay, no compound is optically active. Okay, and next here for this one pair of enantiomers exists for bromochlorocyclopentene. It is one of the important question. For this one here in this case 4 enantiomeric pairs we could see. Okay, so that is just calculation of some isomers. Okay, so thank you for watching. Please like and subscribe my channel.